Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Ein Spatz, ein Satz. I think that's how you pronounce it. Ein Spatz. It's Spatz, I think. Ein Satz. And it's by Sandra and Nala. And here are the rules. Well, actually, first of all, I don't even know what that means. It's one something and then one something else. My German's pretty much non-existent, so I just know a couple of words, like the the counting numbers. So that's. But anyways, let's get to the rules. One thing that never gets old for Nala is to jump scare sparrows that are having a chill time at the lake. She loves it when they fly away while cheaping insults at her. Since the lake we visit today is part of a protective landscape, we must not disturb nature as we take our walk. Easier said than done with all the sparrows around. So here are the real rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 in every row, column, and box exactly once each. Additionally, the grid is partially covered in fog. Placing correct digits will clear the fog from surrounding cells, possibly revealing more clues. So this is typical fog of war. So if you place the correct digit here, it would clear the fog in the cell and in the 3x3 box that surrounds it. So that's how typical fog of war works. We need to draw an orthogonally connected looped path around the fenced lake area. The looped path is not allowed to touch itself orthogonally and does not branch. The loop path functions as parity line, which is even and odd for the digits on it. Okay, so we need to draw an orthogonally connected loop path. And what does it mean to be orthogonally connected? It means you have to be able to go through edges, essentially, on this path. That means you cannot have a path go something like, say, this and then jump there. That's not allowed. You can only go through edges on this path. So you could have a path like this, though. That would be perfectly valid. And it's looped, so it must complete all the way around. So this is an example of a looped path, which is valid. It cannot branch, so you can't split it off into multiple directions. It just has to be... So basically, the way I like to put this is on this loop path, every cell on the path must share exactly 2 edges with 2 other cells on this path. Does that work? Yeah, okay. And the reason why is that this path cannot touch itself orthogonally. So you cannot do something like go like this. This is not allowed, right? So therefore, essentially, the path would be going something like this. That's not right. We want center only. So the path cannot do something like that because it would be considered touching itself orthogonally there. Which is why the constraint of every cell on this path must share an edge. Actually, this is probably a better way of putting it. Must share an edge with exactly 2 other cells on the loop. Right? This shares an edge. This cell shares an edge with 3 other cells on the loop, which invalidates this as a valid loop. But if we remove them, these no longer go that way. We now have every cell on the loop shares an edge with exactly 2 other cells on the loop. Right? This now shares an edge with 2. This now shares an edge with 2. And then so does every other cell on the loop. And the loop's path functions as a parity line. So for example, if this were, say, even, you'd have 2, 4, 6, or 8. These digits that are neighbors on it would have to be odd. So they would have to be 1, 3, 5, 7, 9. And that's how the loop works. We also have to draw it around this fenced area. So it cannot go into this fenced area, I assume, because it's into the water. It's into the lake. Since there are a lot of sparrows scattered everywhere, there will be some unavoidable accidents. But if we see a sparrow in time, the path is not allowed to enter the sparrow cell or any of its 4 orthogonally neighboring cells, because otherwise Nala would charge at them. Okay. Successfully dodged sparrows are maximum cells, where each of its 4 orthogonally neighboring cells is smaller than the digit in the sparrow cell. Okay. So I don't understand what the if we see the sparrow in time. But it sounds like, for the most part, sparrows cannot have the path in the sparrow or around the 4 orthogonally neighboring cells, which just means the cells that share an edge with the sparrow cell. So that would be, for this example, this cell and these 4 cells are not allowed to have the path on it. If we see it, but I don't know what that means if we see the sparrow in time. We'll see that. Maybe that'll be explained later. So technically technically it's still potentially valid, but it's very unlikely that this is actually completely valid here. But anyways, so do we read? Okay. So the sparrow, again, acts as a maximum. So that means each of its 4 orthogonally neighboring cells, which means cells that share an edge with it, are smaller than the digit in the sparrow. So to be a valid maximum, it could be something like 6 here, 4 and 4 here, and then this is 1 and 3. That could work because the 6 is greater than all the cells that share an edge with it in this case. So that's an example of how sparrows work. And remember, if we see the sparrow in time, we have to avoid the sparrow and the 4 cells that share an edge with it for the path. What does it mean to be seen in time? Some sparrows appeared seemingly out of nowhere, and we were way too close once we noticed them coming. Those will unavoidably be charged at. Okay. The path, once it has entered into one of the 4 cells surrounding a sparrow, must go into the sparrow cell as well. Attacked sparrows are minimum cells, and each of their surrounding 4 orthogonal neighbors have to be higher than the digit in these sparrow cells. Okay. So that means that's the opposite of this. So if we assume Nala goes to one of the 4 cells that is neighboring a sparrow, an unexpected sparrow, then she must charge, or she will charge toward the sparrow. So we have to enter, the path has to go through that sparrow cell, and the sparrow is attacked. And attacked sparrows are minimum cells, and each of their 4 surrounding or 4 orthogonal neighbors, which are the cells that share an edge with it, have to be higher than the digit in these sparrow cells. So assuming that this is the path, then this must be an attack sparrow. So it must be a minimum. So we could have something like 3 opposite 8 and 8 and 7 and 4. And this would be valid because 3 is less than all the cells that it shares an edge with. Okay. But we don't have any differentiation right now between when sparrows seemingly appear out of nowhere and when they're too close. Well, okay. Yeah, we don't have any information there. So the sparrow could be completely avoided, or it has to be able to be... It has to be tacked. So the thing is, we don't know what... It doesn't seem to be much differentiation between which sparrows we see well beforehand and which sparrows we don't. So I think that has to be determined by the solver. Digits separated by a white dot are consecutive, and digits separated by a black dot are in a 1:2 ratio. And not all possible dots are given. There is no negative constraint. So, for example, if this were a 7, this would have to be 6 or 8 to make sure that these digits are consecutive. Because there's a white dot between them. Say this was a 2, then this would have to be 1 or 4 to make sure that these digits are in a 1:2 ratio. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so this digit is in a 1:2 ratio with 2 other unique digits. So this must be 2 or 4. 2 is in a 1:2 ratio with 1 and 4. And 4 is in a 1:2 ratio with 2 and 8. What we do know, then, is in this box, the 2 and the 4 in the box have to be one of these 3 cells, right? Because if this is 2, these are 1 and 4. If this is 4, this is 2 and 8. So therefore, there's no possibility for 2 and 4 to be any of the rest of the digits in the box. So we have a guaranteed 2 and 4 here. This has to be essentially 1, 2, 4, and 8. The path, so where can the path not be? The path cannot be here, because if this is on the path, one of these digits is going to have to be, this is already even, and then one other digit on this path must also be even, guaranteed. And to enter this path and exit out, which you have to do for a loop, you would have to enter in even, which is not allowed. So this is not on the loop. What do we mark that with? Let's mark it with pink. Pink is not on the loop. So Nala could potentially just enter this cell and then exit. That's possible. If she does not, if we see the sparrow in time, that means she has to go in this direction. But the problem with, well, it could be even. And then these are all odd. So that is possible. We also, well, So that's possible. So for the loop, either Sandra and Nala go this direction and avoid the sparrow, or they charge directly to the sparrow. We don't know. And it could just basically charge that way. These digits cannot contain 2 or 4, so they must contain 6 or 8 here. So this must be 5, 6, 6, 7, 7, 8, or 8 and 9. And one of these is going to be even. The other one is odd. So what happens if Nala goes this way? Then these are guaranteed to be both the same set of parity, and one of them is definitely even, so that means the other one would have to be even. So this would be 4, 2, and 8 there. this would have to be odd, even, odd, even, odd. So all of these would be odd, and therefore that would be 6. We would avoid that one. Does that tell us very much? Not really. Maybe this is a seen sparrow because we see the sparrow already. I think that's what it might mean. Otherwise, I don't think this is solvable because you could have any variety of things going through this area. But if we could assume that this is seen, and the thing is, this is not. There's nothing that eliminates this possibility from being the case, right? If you go directly in it, you could do any path to go into it. So we don't really have enough information. But we see this sparrow in time. So the path is not allowed to enter the sparrow then, if that's the case. Which means we have to go as a loop around. It has to go this way. So this has to be on the loop. This is even, and we know both of these have to be even then because one of these is guaranteed to be even. Therefore, all of these are odd. Since this is odd, this has to be even, and the rest are odd. Because we have 4 evens already in the box. Well, for both of these to be even, this has to be a 4 then. And so, yeah, I'm thinking what we're saying is if we see a sparrow, so we've already designated a path. If we see a sparrow, we have to avoid it and the 4 cells that share an edge with it. So this is definitely on the path. So then this has to be 4. So we have 4 here. This has to be 2 and 8 here. And this must be an even digit next to 2 unique odd digits. So this is, we already have 2, 4, 8 accounted for. So this is 6. This is getting hairy with a number of colors we have here, but anyways. So 6 is next to 5 and 7, which leaves this digit as a maximum since they are dodged. It has to be greater than 9 and it cannot be 5 or 7. So it has to be greater than 6 and it can't be 5 or 7 and it has to be odd. So this is 9, which leaves this as a 1-3 pair in the box. This must be even, and this must be even. This is consecutive with another digit, so this is odd here. And this is in a 1-2 ratio with another digit, so that must be even. Okay. We avoid these again. The only odd digits which are in a 1-2 ratio are specifically 1 and 3. And they are in a 1-2 ratio with only 2 and 6. So this is 2 or 6. This can't be 4, so this is 2, 6. It's consecutive with this digit. Well, if this were 2, this would be consecutive. If this were 1, this would be consecutive 2 and in a 1-2 ratio with 2, so that's not possible. So this must be 3 here, which is in a 1-2 ratio with 6. 3 eliminates 3 here, so it's 1 and 3. This digit's consecutive with 3, but cannot be 4, so this is 2, which makes this 8, which makes that 2. We have to avoid the sparrow that we do see. So we avoid all those cells, so the path has to go this way. Which means this is odd, this is even. Since this is even, this must be odd. Let's just remove all the greens because pink is sort of unavoidable to basically signify where the path cannot be, but we could so far go this way. So the pink is a maximum. Which has to be greater than 2 unique digits, which are not 2 and 3, so it's at least 1 and 4, which means this could be 5 here. But this digit is odd, and it's next to 4 or 8. And 3 can't be here, so this is at least 5 here then. So this has to be 5 or 7 because it can't be 1 or 3 because of 1 or 3 in the column. Because if it's not, say it was 9, if 9 is here, then this digit will not be a maximum digit. And we avoided charging at that one. So this has to be 5 or 7, which is consecutive with 4 or 8. This digit must be greater than 5 or 7, so this is 7, 8, or 9, because it cannot be 6. Remaining digits in column 2 then are 4, 8, and 9. Okay, 8 can't be here because of 8 in the column, and it must be greater than that, so this must be an odd digit. Interesting. These digits must be less than at least, it has to be less than 9 at the most. So these remaining digits in the box, where is 9? This can't be 9, and this can't be 9 because this has to be greater than both of them. And these can't be 9 because of the 4, 8, and 9 triplet in the box. So where is 9? 9 has to be here. So that's 9. These are in a 1 to 2 ratio, therefore 9 cannot be either. 9 cannot be either of those. So this is 4, 8 as a pair, which means this can't be 4, 8. It's 9. We see this sparrow, so we must avoid that sparrow and the 4 cells surrounding that share an edge with it. So that means we have to go this way. So the path has to go this way through that, and then it has to go through there. This digit then is a maximum. These are both even. We cannot go through any of these because we're blocked by these cells here. These are both even. This is odd. This then has to be odd because you alternate between odd and even. That's even. This is odd. So the only odd digits which can be next to a black crop key dot, again, are 1 and 3. I don't know if I said that specifically. But the only odd digits that can be next to a black crop key dot are 1 and 3. It has to be in a 1 to 2 ratio with 2 and 6, but this can't be 6 because of 6 in the row. And this is even, so this must be 2, which makes this 1. This digit is in a 1 to 2 ratio with a black crop key dot with another digit. And it can't get, again, it cannot be 1, because if this is 1, that's consecutive with 2, but also in a 1 to 2 ratio only with 2. And we'd have a repeat in the box. So this has to be 3, which is in 1 to 2 ratio with 6. We have to go on this path, and this is a sparrow we did not see beforehand. So we have to go directly toward the sparrow. So this is even. And it's a minimum from all the digits on it shares an edge with. So it must be less than 3, and it's a minimum, so this has to be 2. This is even here. We cannot go this direction, so we go to one of these two. We don't know which. We cannot have 1 share an edge with the 2. So where can the 1 be? Can't be here because that's 1 to 2 ratio with 3. Can't be here because of 1 in the column. So it can only be here because this must be minimum. It must be smaller than all the cells it shares an edge with. Therefore, 1 is here. This is in a 1 to 2 ratio. It cannot have a 2, which means 1, 2, and 2, 4 are eliminated. If it's 4, 8, that would eliminate all possibilities for that cell. So this has to be a 3, 6 pair. Which means, where are 3 and 6 in row 9? 3 and 6 cannot be here because of 3 or 6 in the box. This is odd and is 1. These can't be 3 or 6 because of the 3, 6 pair in the box. So where 3 is 6, they have to be here, which means this can't be 6, it's 3. This can't be 3, so that's 6. This is a maximum. Remaining digits in the box are 1, 2, 5, and 7. So it must be greater than 3, so this can't be 1 or 2. This is 5 or 7, which means this digit has to be less than it. And 8 is not less than 5 or 7. So this is 4 and this is 8. Again, 2 can't be here because of 2 in the row. This can't be 2 because of 2 in the column. Where is the 2 in this lower left-hand box? It must be here. So that's 2. This digit is a maximum again. It must be less than 5 or 7. And it cannot be 1, 2, 3, or 6, or 4. So this has to be 5, which makes that 7. And that makes that 1. So that's 5 there. 7 here eliminates 7 here, so that's 5, which makes that 7, which eliminates 7 here, so that's 5, which is only consecutive with 4. That means this is odd. Remaining digit has to be odd and even, so this is 1, that's 8 as an even, and this must be 7 as an odd. So we have evens here, odd here. These are odd. We have even here. These are odd. We have even here. So this is the last even in row 7 because we have 2, 6, 8 already accounted for. So this must be 4. This cannot be on the path because Nala charges at the Sparrow that came unexpectedly. The remaining digits in row 7 are all odd, and they have to be 1, 7, or 9. That means... where can we enter as the path? We have to go around. It can't go through there because then it would be considered touching itself. And if we try to go, say, odd, even, odd, that could work. We cannot go this way because it would have to be odd, then even, but that's not an even digit. So to form a valid loop, we have to go this direction, which makes that even. Then we could, no, sorry, that's odd. This is odd. It cannot go that way. It cannot touch itself, so it must go that way, which makes that even. So this is odd. It cannot be 1, 5, 7, 3, so this has to be 9. Which forces this to be 6 here. That's 3. So this is odd. We see this Sparrow and without charging, so we cannot go on any of these paths. So we cannot go here. None of these are valid. So we cannot go into this path. It has to go that way. The path must go there. It goes odd. It cannot go that way because that's odd. And so therefore this must be even here. So this is even as a path. This has to be greater than all 3 cells that it shares an edge with. So this cannot be 9. This has to be 8. This is 8 as a last even digit in row 8. Remaining digits in this lower central box are 7 and 8. We don't know which is which. These are all greater than this 2, though. So 8 is greater than these digits here, and this is, what, 2, 4, and 5. Okay. This is 1. This is 1, 7, or 9. That's fine. Remaining digits in column 4. We have 3, 6, 7, 8, 9. No 3 or 9 here. This can't be 3, 7, or 9 because it's even. No 6, 7, 8 here, so that's 3 or 9. No 3 or 8 here because of 3 or 8 in the row. So where is the 3 in column 4? Can't be here because it must be even. Can't be here because of 3 in the row. Can't be here because of 3 in row. Can't be here because of 3 in the column. So it has to be here. So this is 3 and is odd. We have just seen a sparrow, so we have to charge straight through. So we charge into the sparrow. It's odd. And it's less than all the cells it shares an edge with. So it cannot be 3 or 5. It cannot be 9, obviously, so this is 1 or 7. But 7 is less than only 2 other cells in its box, and it has to be less than 3 cells in the box. So this cannot be 7. It must be 1. Okay, we don't know which direction she goes after that. This can't be 4 or 6, so this is 2 or 8. If we have 2 here, this would have to be 1 or 3 because of that's what it's consecutive with, but this can't be 1 because of 1 in the row, cannot be 3 because of 3 in the column, so this can't be 2. This must be 8, which makes this 7 there to be consecutive with it because 9, we already have 9 in the row. Therefore, she must charge at the sparrow, and this must be odd also. 7 eliminates 7 from being here. This is odd. Must be a minimum, so it's smaller than all of these cells. So it could be 3 or 5 because it can't be 1 or 7. Okay. Remaining digits in row 6. We have 2, 3, and 6. This can't be 2 or 3 because of 2 or 3 in the column, so this is 6, which eliminates, and this can't be 2 or 6 because of 2 or 6 in the box, so that's 3. Therefore, that leaves that as 2. No more 6 here. So we know these are even. This is odd. This is odd. We have even here. So this cannot be 2. This is 3 or 5. Where is 1 in this right central box? Can't be here because of 1 in the row. Can't be here because that would be less than this digit, and this digit has to be a minimum, remember. Can't be here because 1 is only consecutive with 2, and we already have a 2 in the row. So 1 has to be here. These digits are consecutive. Cannot contain 2 or 8 as the even digit. So it has to be 4 or 6 here. 4 and 6 are consecutive with 3, 5, and 7, but 7 can't be here because of 7 in the box. These can't be 3. This must be 5, which is consecutive with 4 or 6, which eliminates 5. This can't be 6 here. That eliminates 5 in the rest of the column and box, so this cannot be 5. This is guaranteed to be a 3. Now, these digits are consecutive. It cannot have 6 or 8 be the even digit for this consecutive pair because we have 6 and 8 in the column. If we try to have 2, it's only consecutive with 1 and 3, and this digit can't be 1 or 3, and it can't be 2. So this has to be 4 with either 3 or 5, and 3 cannot be either of these, so this must be 5. So these are consecutive as 4, 5, which eliminates 4 and 5 in the rest of the column. This can't be 4, 5, it's 2. This can't be 2, it's 4, which makes this not 4, it's 5. 4 eliminates 4 here, so that's 5 and 6. This can't be 5 or 6. It's 4 or 5. That leaves, so this is even. This is odd. The rest of column, so since this is 2, that's even. This is even. This is odd. This is odd. This is even. This is odd. That means the rest of row 4, we have 4 even, so the rest have to be odd. Same with the rest of column 7. We have 4 even, so the rest must be odd. So 3 cannot go to an odd digit. It must go to an even digit. It can't go to an even digit next. It must go to the odd digit. We don't know which direction she goes afterwards. It's one of these two. So these are 1, 7, and 9 as possibilities because those are the remaining digits left. This can't be 7 because of 7 in the row. This can't be 1 because of 1 in the row. These are all odd digits remaining. Remaining digits in row 4 then are 5, 7, 9. This can't be 9 because of 9 in the column. And that's it. That's all we have. Okay. The remaining, so 1 eliminates 1 here, so this is 7, which means this cannot be 7 here. We have a 1, 9 pair in column 7, which eliminates 1 and 9 in the rest of the columns. So this can't be 9 here, it's 7. Remaining digit in this right central box is 9. Remaining digits in row 5 then are 4 and 8. Okay, and these are both even. Okay. Does that tell us very much? I don't really know. Remaining digits in column 9 are 3, 4, and 6. This can't be 3 or 6, so this must be 4 because of 3 or 6 in the row. That means this can't be 4. This can't be 3 or 4, so that's 6, which means this can't be 4 or 6. It's 3. That's 3 in the corner. We celebrate because we're close to solving this. Remaining digits in, let's do row 1. We have 6, 8, and 9. And this can't be 9 or 6 because of 9 or 6 in the column. So this is 8, which makes that 6. This can't be 6 or 8. It's 9, which eliminates 9 here. So it's 1 and 9. That eliminates 9 here. So that's 1. So Nala cannot go around in a loop this way because these are both odd. And can't go here because that would be considered touching itself. So she has to go this way. So this must be even. 8 is even. Also, 8 eliminates 8 here, so that's 4 and 8. The last remaining even digit in column 6 must be a 2. And this is odd because we have 4 evens in column 6 already. So she goes this way. She could go one of these two directions. She could go one of these two ways. But this cannot be even because we have 2, 6, 8, and 4 already accounted for seeing that cell. So therefore, she has to go this direction. And again, cannot go 7 here, then 9 here. It has to go here, and then can't just touch itself, so it has to go down. And this is odd anyways. So we know this is odd. This has to be even as the last digit, and this must be a 2. This can't be 6 or 8. It's 7, which makes that odd. 7 eliminates 7 here, so that's 9, and 7 here, so that's 8, which makes that 7. This can't be 7 or 9, so it's 5. That eliminates 5 from being here, so that's 7. And the remaining digits here are 8. This is then 4. This is 9, and we have a 5 here. The solution is correct. Oh no! Nala ended up jumping at 3 sparrows on our walk today. She enjoyed that walk a lot because of the additional amusement those sparrows provided for her. Luckily, no birds were harmed and no one saw what Nala did. Hopefully, her secret is safe with you. Okay, I do wish that we had basically been clarified that basically the seen sparrows are the ones that we see before we actually enter. We have the path enter that area, right? And we see the sparrow. I mean, I guess we could sort of infer that, but it's not very clear that that's the case. Um, Still a very cool puzzle. Very nice use of the fog of war to know what seen sparrows and what unseen sparrows are. Um, yeah, it's just I mean very well constructed. I just would like I wish that the rules had a little bit more clarification about what is a seen sparrow and what is not seen as a sparrow. Um, Other than that, very cool puzzle. And I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.